Good morning, all. So let me share my screen. So by that you can view my screen clearly. Okay. Yeah. So first, let's see the important definitions which are related to the practical applications. And today I would like to, show very important videos where you can understand the real behavior of the structures and you can relate them with your theoretical, whatever the theoretical knowledge you have. Okay. Guys, is my screen visible to everyone?
Yes, sir.
Yeah. So first of all, how strong we are in this subject, let me show you first. So this is a complete, data which I have on these principles of bridge engineering, because I dealt the same subject for MTech course, MTech structures. So we have complete notes. Okay. Don't worry about the notes at all, because, problems, everything, we have a proper notes. And for unit 1, we have PPTs, we have videos, everything. So you can really feel, because I couldn't able to take you to practical structures, but I can make it possible by showing all structures which I have worked in, and at the same time which wherever we are discussing some points, definitely we can relate those points with the practical applications. Okay. Yeah. So that's how we are very strong in this subject. So you can feel very happy by opting this subject as your open as a professional lecture. Okay. Yeah. So first, let's see these videos first.
All infrastructure design and development, like buildings, bridges, highways, dams, etc., are dependent on our scientific understanding of this subject, called strength of materials. This subject is also known as mechanics of solids. Now let us study a bridge on which hundreds of vehicles and trains cross daily. Strength of the bridge structure is sufficient to take this load of vehicles, trains, etc. How? Because of the ability of the structural design and materials used to withstand the load without failure. Engineers like you design and select the materials required to construct this bridge after calculating the strength required of the columns, beams, shafts, etc. Engineers also plan and design this bridge to avoid wastage of materials, ensuring strength and stability. If an external force is applied on a material, it will have some internal resisting force and may deform. The subject of strength of materials deals with relationship between internal resisting forces, deformations, and external loads. Structural elements of the bridge, which are getting loaded, develop internal forces. These internal forces are known as stresses. Simplest form of stress is either tensile or compressive in nature. Tensile stress. It is the stress caused by an applied force to elongate the material along the axis of the applied force. In other words, it is caused by pulling the material. Let us consider one of the structural elements of the bridge.
Guys, sorry for interruption, because as I told you many times, for any subject there will be prerequisites. Okay. I don't know how many of you recollected all the things which you have learned in your first year, second year, and third year. So that is the reason why I would like to revise these basics. Why? Because these basics are very, very important for bridge engineering, because we are going to deal all these kind of stresses, forces, loads, everything, because this is a major primary thing. So where one should know all these basics before starting this subject. Okay. So that is the reason why I would like to show all this before starting off our subject. Okay, guys. Right.
As the car passes over the bridge, horizontal component of the force due to the motion of the vehicle pulls the structure. We call it as tensile force. Due to this, tensile stress is developed in the structure. What is compressive stress? It is the stress caused by an applied load that acts to reduce the length of the material along the axis of applied load. In other words, it is squeezing the material. Weight of the moving train on the bridge compresses the element, and the stress developed is called compressive stress. A more complex type of stress is shear stress. It is caused by a pair of opposing forces acting along the parallel lines of action through the material. In other words, it is caused by sliding the faces of the material. Now look at the structure element riveted at the joint. We find that the load is acting on opposite directions.
Right, guys? So now I think you can relate how bolt is subjected to shear, right? So because practically, I mean, I couldn't able to show you in presentations when we are dealing with the design of steel structures. At least now you can able to understand. So when two angles, so here you can observe two angles which are connected each other, which are lapped each other, right? So where the bolt is subjected to shear, so there the shear stress happens, isn't it? So this is how you can relate every problem and every concept, okay, practically with the real applications, right?
And trying to shear off the rivet. The stress acting on rivet is called as shear stress. It is caused by a pair of opposing forces acting along parallel lines of action through the material. How do we measure stress? Stress is defined as resisting force per unit area, but in equilibrium condition, the resisting force is equal to the applied force. Thus, we can say stress is force per unit area and is expressed as sigma is equal to P upon A, where A is the cross-sectional area, P is the external force. Another important concept is strain. Strain is the deformation in the material developed due to stress. Strain is the representation of extension or compression of a component under load. Strain is dependent on the geometry and the material properties of the component and is defined as the change in length divided by the original length. Similar to stress, there is tensile strain and compressive strain. Shear strain is measured by the angle through which the body distorts due to stress. For
Okay.
infrastructure design and development, like buildings.
Okay, so I hope you all understood, I mean, at least recollected what are the stresses and all, isn't it? Guys, andarki screen kanpichinda? I mean, have you all viewed the video? Hello? Hello?
Yes, sir.
Yeah, fine, because at least someone can respond. So because if any problem, so please inform me immediately, guys. So please don't write anything on the screen. Yeah, and one more thing I would like to show you. How many of you know about how can you differentiate the under reinforced beam or reinforced beam, right? How the RCC behave, how it is going to fail under shear, how it is going to fail under bending. Okay, so I have 4 videos where I would like to show you, so please you can also watch these. Okay, right. So first let me show you first one, behavior of a reinforced concrete beam, so where it is subjected to bending. Okay, right. So this is a normal reinforced concrete beam. So when it is subjected to load, how it bends. Okay, and what about the bending cracks, how the bending cracks takes place. Okay, that you can able to see in this video. Right. So now there is a question. Can anyone tell me what type of loading it is? Guys, please respond. What type of loading it is? I want you to respond. Guys, please respond immediately. What type of loading it is?
Simply supported point load.
That's what. What type of point load it is? Is it 1 point loading or 2 point loading or 3 point loading?
2-point loading.
2 point loading. Okay. Right. Now, so this is how the beam reinforced. Okay. There is a main reinforcement and there is a stirrups which are provided at on either supporting sides. Okay. Yeah. Now tell me what type of loading it is. Guys, please respond. What type of loading it is now? Anyone?
Point load.
Huh? What type of loading it is? So just now you have seen there are 2 point loads. One, this is 1 point load and this is other point load. Over to this, there is a beam which is again loaded with 1 point load here. So total, how many points are there here?
3.
3 points. Okay, that means the load W, which is dividing into W by 2 and W by 2. Okay, so this is called 3 point loading. Understand? Can anyone describe me why the loading is in this way? Why can't it be just a point load, just a single point load? Why this W load is distributed to W by 2 and W by 2 to calculate the pure bending? Can anyone? Anyone? See, if you apply directly point load on the beam, what happens? You can't get the pure bending. Okay. So why? Because at the point, at the center point, you will get shear force along with the bending moment. Okay. So when you divide this point load into 2 equal halves, like W by 2 and W by 2, in this span, okay, in this center span, the shear force will be 0 and there will be only a pure bending. Understand? So that is the reason why whenever you test beams to have a pure bending, so definitely you have to divide the load into 2 equal halves. So where you have to apply a 3 point loading to have a pure bending. Understand? So that is the reason why load is divided into 2 equal halves, where the beam is supposed to be loaded as a 3 point loading instead of a single point loading. Understand? Clear? Right. Let's see how the beam is going to behave, okay, to know its bending. See, whenever you find cracks like this, okay, see, you can see the vertical crack and the main reinforcement, is failing here, right? So this is how the beam fails in a form of a bending, like a pure bending. See, there is no failure at supports. You can clearly observe. At this end, at left end and right end, you can't find any kind of cracks, right? Why? Because here beam is subjected to pure bending. Understand? So that's why there is no cracks at all at the supports. At the same time, why there is no cracks? Because your beam is properly reinforced, okay, with shear reinforcement at both ends. So that's why there is no shear crack at all, right? And if you want to see the behavior, I mean, a graphical representation between total vertical load towards beam deflection, I mean, mid-span deflection. See, the deflection curve is increasing, okay, to the point where it will have the maximum deflection, and then it gonna fail completely. Understand? So this is how, if you want to draw a graph between load versus deflection, so you can find a graph like this for pure bending, okay, beam. So I can call it as a linear graph, linear curve. Why? Because your load is directly proportional to deflection, isn't it? So by this you can drag, or you can get the elastic constant, Young's modulus, even from this graph. Clear? Right? So not only elastic constant, so flexural constants are also there. What are the flexural constants for a pure bending equation? Can anyone? What are the flexural constants from the pure bending equation, Amma? What are the flexural constants? Please respond. In the time this customer. See, there are many students. So if you're not responding, so it's a waste of time again. What are the flexural constants? What are the flexural constants? Weight in flexural constants under. Guys, are you hearing me or not? Hello? C, E, and I are the flexural constants. Young's modulus of the beam, I mean, of the RCC beam, and I, moment of inertia of your specimen. Okay, these two are called flexural constants. Okay, right. So let me show you another video. So this is the one which is behavior of a reinforced concrete beam with no shear. With no shear links. So in the earlier video, you have seen beam completely have a main reinforcement along with the stirrups, right? So what is the purpose of the stirrups? What is the purpose of the stirrups, Sama? What is the purpose of the stirrups? What is the purpose of the links?
No.
To control shear cracks, right? So links will have shear stress. Okay, they will control the shear cracks in the beam. Now, if you remove the links, if there is no shear links provided in the beam, what happens? How it gonna fail? Let's see the video. See again, same beam with the 3-point loading. Yeah, so this is the reinforced structure of the beam. So there is only a main reinforcement which is provided at bottom level, right? So to take care of the tensile stresses. So there is no top reinforcement and there is no stirrups at all. Now see how your beam is going to fail when there is no shear links. See, if any beam fails at support where the crack is in an inclined way, okay, not vertical, inclined at an angle of 45 degrees, okay. So if you find any crack like this, so you need to immediately understand that there is no shear stirrups or shear links provided. So that is the reason why it got failed in a form of a inclined crack, so which is failing under shear. Okay, so that is what an understanding you need to get when you see any cracks in the beam. Okay, right? right? Have you seen? Yeah, this is what the shear crack. Okay. See again, if you see the graph between total vertical load towards the deflection, again, you can find the linear curve and there is a sudden drop. There is a sudden drop. Why? Because there is only an elasticity nature till this point and there is no plastic nature. Why? Because your concrete is a brittle material. Okay, brittle materials doesn't have any plasticity, isn't it? So that's why you can't find any kind of, plastic behavior in the concrete, right? So when it is not having any kind of shear links. Okay, so that means the the understanding, what you have to understand. So when there is no shear links, so definitely you can find a sudden failure. Okay, immediate failure in the beam. Okay, when there is no shear links, so which is going to be called as a, it's an emergency failure. Okay. So without any warning, it is going to fail, right? Yeah. So that is what about a beam which is not having any kind of shear links. Okay, next, let's see behavior of an over-reinforced concrete beam in bending. Okay, can anyone differentiate what is the over-reinforced beam and under-reinforced beam? Anyone? Anyone from the class? There are 40 students. I want at least 1 or 2 students. So please differentiate what is the difference between over-reinforced and under-reinforced beam. Guys, you have to, because you are preparing for GATE, you are preparing for competitive exams. Now you are almost graduate students. You should know all these basics. Can anyone please unmute and tell me what is the difference between over-reinforced and under-reinforced beam? Anyone? See, Chapanamma, Abhishek. Rathod Vamshi. Guys, if you are not responding, how can you continue my class? Tell me. మీరు మినిమం అసలు రెస్పాండ్ అవ్వకపోతే ఎట్లా? చెప్పండి, ఎవరైనా ఆన్సర్ చేస్తారా?
టెన్షన్ కెపాసిటీ.
ఓకే.
అండర్ ఎన్ఫోర్స్డ్ అంటే కాంక్రీట్ ఫెయిల్ అవుతుంది సార్.
ఓకే, అండర్ ఎన్ఫోర్స్డ్ అంటే కాంక్రీట్ ఫెయిల్ ఫస్ట్.
స్టీల్ ఫెయిల్ అవుతుంది సార్ అండర్ ఎన్ఫోర్స్డ్ అంటే. ఓవర్ ఎన్ఫోర్స్డ్ అంటే కాంక్రీట్ ఫెయిల్ అవుతుంది.
Okay, so let's see whether your definition is right or wrong with the practical, experiment. Okay, right. So let's see the video of behavior of a over-reinforced concrete beam in bending. Again, same kind of setup. Right. So which is over-reinforced beam? So which failed first, Amma, in over-reinforced beam? See, first let's see what is the reinforcement provided in the over-reinforced beam. So there is a main reinforcement and the stirrups which are provided with a spacing. Okay, so in over-reinforced beam, when it is subjected to load, so what happens? Which failed first? Concrete or steel? Air fail in the first concrete or steel?
Concrete.
Very good. So the definition, nothing but the strain of concrete. Okay, it is going to be reached before the ultimate strength of the steel. And so before getting the ultimate strength to the steel, your concrete will fail first. Okay, so the yield strain of concrete is going to be reached before the ultimate strength of steel. So that is how over reinforced beams undergo a compression failure. Understand? So over reinforced beams will undergo first compression failure. So it is always advisable to go for under reinforced beam. Why? Because it is so safer when we compare all kind of different beams, because there are under reinforced beam, over reinforced beam, right? Like balance section and all. That is the reason why we always prefer under reinforced beam, because as the concrete is brittle material, your concrete will fail first because it is undergoing compression failure. Understand? See, తెలియని వాళ్ళు రాసుకోండి. Okay, so because all these practical experiments you didn't do in your BTech, so that's why if you at least to see these, you can able to remember. Okay, the slow motion you can easily see how the concrete is failing first. Right, so this is how the graph looks like for a vertical, for the load versus deflection. Okay, right. And last, finally, behavior of an under reinforced concrete beam. What is this? What do you mean under reinforced beam, mama? So under reinforced beam is the one so which the tension capacity of the reinforcement, nothing but tensile reinforcement, is always small than the combined compression capacity of the concrete. Okay, so that is the reason why we always prefer the under reinforced section, where the tension capacity of the reinforcement is very small compared with the combined compression capacity of the concrete and the compression steel. Okay, so that's why we always prefer this under reinforced beam. So let's see how the under reinforced beam fails when it is subjected to bending. See, again, see the setup of the beam. If you see the reinforcement, so there is only a main reinforcement, there is no stirrups at all. Okay, so this is how you have to test an under reinforced concrete beam. Right, have you seen how the over reinforced beam, under reinforced beam failed? And again, you can straight away relate, there is a shear crack because there is no shear reinforcements provided, shear links provided. So you can find the shear crack exactly at the support, near to the support. Okay, and you can find the difference. And under reinforced beam, so there will be a horizontal and an inclined crack, and even the graph difference also you can able to observe, right? So the load capacity of under reinforced beam will be less when there is no stirrups which are provided as a shear links. Okay, okay guys, right? So now let me show the compressive stress strain curves, because these are all very important when you are studying this bridge engineering, right? So see, now you can see how the stress strain curve of a concrete for an age of 4 days, okay, for of the 4 days of curing. So because you all know the compression stress or compression strength of concrete can be tested either in a cube or either in a cylinder, isn't it? So this is the setup where you can able to observe the stress strain curve of a concrete. Guys, even this setup was there in our college. Because none have used this. So if you want, you can test it and you can observe really how the stress strain curve for a concrete looks like. Because as concrete is a brittle material, so you can't able to drag the stress strain curve for the concrete easily. So that's why there is a computerized way where you can able to observe the stress strain curve. See, there is a linear curve which is observed here. From this only you are going to get the Young's modulus of the concrete. Okay. And again, Young's modulus of the concrete is always depends on what? Grade of concrete. Okay. Grade of concrete will definitely varies the Young's modulus of concrete. See, till this point, the graph is linear. Okay. So this is how the stress strain curve of a brittle material, nothing but concrete, looks like. Okay, guys. So there is 1 minute left, Amma. So please join again with the same link after 10 minutes. Okay. So please be on online with the same link. I will again join in another 10 minutes. Okay. So then we can continue the next class also. 1 minute, 1 minute. Okay, Amma. Fine. Guys, are you all okay? With the same link, please join again in another 10